Hello everyone, welcome to Sam's Science View channel. In today's video, we are going to listen to a science fact. Where do butterflies get their striking colors? Before getting into the video, please watch this entire video, and if you have any science related queries, you can clarify it through this channel. Now let's get into the video. Butterflies possess some of the most striking color displays found in nature. As they fly from flower to flower gathering nectar, their brightly colored wings seem to shimmer and change colors before your eyes. Pilots flying above the rainforest can see the bright blues of the morpho butterfly of South America up to half a mile away. A butterfly's rich color can act as camouflage, mate attraction, and warning signal. But what is it that makes the vivid colors of butterfly wings appear to dance? How can they possess such intense hues? Butterflies actually get their colors from two different sources. One from ordinary or pigmented color, and the second is a structural color. The ordinary color comes from normal chemical pigments that absorb certain wavelengths of light and reflect others. For example, the pigment chlorophyll colors plants green. Chlorophyll soaks up the blue and red colors of the spectrum, but not the green, which you see when it bounces back to your eye. Most butterflies get their different shades of brown and yellow from melanin, the same pigment that makes you tan in summer and gives some people freckles. The structural color of butterflies is where things get interesting. This type of color stems from the specific structure of butterflies' wings and explains why some of butterflies' colors seem to shift and appear so intense. This quality of changing colors as the observer moves is known as iridescence, and it occurs more in nature than you might think. Mother of pearl seashells, fish, and peacocks are few examples of animals with this quality, but it is most pronounced in butterfly family. It happens when light passes through a transparent, multi layered surface and is reflected more than once. The multiple reflections compound one another and intensify colors. When talking about the iridescence, it helps to remember that light is a wave and can be described as a wavelength. The distance between identical points on the wave is considered to be a wavelength. Waves can also be described by their phase, which is the position of their crests, that is, the high points, and troughs, the low points. When two waves have the same phase, their crests and troughs would align if placed on top of one another. Whether you know it or not, you have likely been familiar with iridescence since you were a kid. You probably marveled at it while blowing bubbles with a wand or playing with bubbles in the bathtub. With the soap bubble, light first passes through the top layer of the bubble where some of it is reflected, while some of light continues through to the bottom layer where again some of it is reflected. Depending on the time it takes the second reflection to join the first and several other factors, the two waves may or may not line up or have the same phase. If the phase of the two waves is different by some multiple of one full wavelength, the two waves are said to have constructive interference. If the two waves differ by half a wavelength or an odd multiple of that, they have a destructive interference. Constructive interference is what happens in iridescence. It causes the two waves to complement each other and strengthen the reflection. The effects of iridescence create much more intense colors than ordinary pigments would ever do it. Destructive interference causes the two waves to cancel each other out and weakens the reflection or destroy it altogether. Basically, when the crests and troughs are more than one wave of light match up, their powers are magnified. When they do not match up, they are mostly destroyed. Okay, you are saying, but butterfly wings look nothing like soap bubbles. So, how do they do it? Not all white coloring is created from pigment. Some of it is actually just bubbles of air that scatter light because of their transparency. The scattering of light makes the object appear white in the same way that snow does. The white hair of humans is similar to that. The individual strands are not actually pigmented white but are filled with tiny air bubbles that replace the ordinary color. When light hits the different layers of a butterfly wing, it is reflected numerous times. The combination of all these reflections causes the intense colors of many species. The same principle behind soap bubbles applies to butterfly wings. Their wings, however, amplify the effects of iridescence because they have many more layers for the light to pass through and thus many more opportunities for the light waves to reflect and magnify one another. As small as they are, butterfly wings are covered by thousands of microscopic scales split into 2 to 3 layers, thus, their Greek order name Lepidoptera meaning scaled wings. In turn, each scale has multiple layers separated by air. Rather than having just the constructive interference from the top and bottom layer that you have in a bubble, the many equally spaced layers of butterfly wings create multiple instances of constructive interference. When light hits the different layers of the butterfly wing, it is reflected numerous times, and the combination of all these reflections causes the very intense colors that you see in many species. Some butterfly displays even extend into the ultraviolet spectrum, which is visible to butterflies but not to humans. This ability to detect ultraviolet light guides monarch butterflies on their annual migration from North America to Mexico. The combination of a butterfly's structural and pigmented color can create interesting effects. For example, if you saw a butterfly with yellow pigment underneath a structure that creates a blue iridescent color, you might see a green shade made by the merge of the two colors, or depending on your viewpoint, you might see blue, yellow, green, or a combination of the three. Your view would change as the butterfly moves its wings and the light enters at different angles. Whether they serve as camouflage or communication, the brilliant, complex wings of painted ladies, red spotted purples, and the thousands of other butterfly species owe their beauty to iridescence and structural color. So, when you see next time a butterfly, you just see the colors of the butterfly wings is being due to the presence of iridescence, and that is the structural color, and the pigment, that is the ordinary color given from the pigment. So that's it for today's video. I hope so you got some scientific facts related to where do the butterflies get their striking colors. If you have any science related queries, you can get it rectified, and you can comment about it. We'll meet in the next Science Fact Treasury series. Until then, it's goodbye from Sam. Take care.